Hey there, Course 1. Lesson 19 talks about a couple things. What factors are again, and then what prime numbers are, which means numbers that don't maybe have a lot of those factors. Let's dive right in. Factors, if you can recall from Lesson 2, were those numbers that are in a multiplication problem that are being multiplied to get to the product. So basically, factors are the numbers that are not the product in a multiplication problem. And so 2 and 3 are the factors of 6, but in a lot of cases there are more than one pair. You always have 1 and 6 for 6, or 1 and any number, right, are factors of any number. But sometimes numbers are what we call composite, which means that they have more than just 1 and themselves that can be a factor. So 6 is composite because it's not only 1 times 6 is 6, but it can claim other factors like 2 and 3 can also come to be 6. And it's all illustrated in division here. You can think of another composite number that would be divisible by more than just that number and 1. Can you think of any? How about 4? Composite because of 1 and 2 and 4, because 2 times 2 is 4. Its factors are 1, 2, and 4. How about 36? Can claim, of course, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Right? So composite, meaning there are lots of factors, or at least more than the number itself and 1. Factors of a given number are the whole numbers that divide the given number without a remainder. So sure, I can divide 2 into 3, but there's going to be a remainder. You're going to get 1 and you're going to get that half. Or if I do it in long division as remainders, 3 divided by 2 ends up being 1, and I always think decimal. 1 remainder 1, right? So that makes it so that didn't count as a true factor. 2 is not a true factor of 3. You can't list it. Even though it does go in, it's not even. Does that make sense? So they show this real nice with some cubes here. If it's a factor, you can evenly form that many, 1, 2, 3, 4, 5, 6 boxes. And the factors would count how many boxes in each side. So there's 1 box wide, so 1 is a factor, and 6 boxes long, so 6 is a factor. 2 and 3 are also ways to arrange it. 10 can be arranged a couple of ways. 1 box wide of a 10 box long row. You could have 2 rows here of 5 in each total. So that illustrates in tiles the factors that go into some of these composite numbers. 12 is one of those that has a lot for just a smaller number. It's got 6 factors for a number that's just over 12. You can even draw and illustrate 18 with yourself if you want to keep working on this. It's a great practice to see how drawing tiles, as long as there aren't any leftover tiles, will not only show whether numbers are composite, but what factors go into those composite numbers. So what's the opposite of composite? Composite meant that it had other factors besides itself and 1. Prime means only factors are 1 and itself. Okay? So as we look down the first 10 natural numbers, which ones count as prime? 2, 3, 5, and 7. How did I know that? Because look, they have exactly 2 factors. 1 and 2, 1 and 3, 1 and 5, 1 and 7. The others all can claim extra factors. Now another way to think of prime numbers is any number that has exactly 2 factors and no more, no less. Because then we remember that 1 does not count as a prime number. The number is divisible by any other number, and so the number is not prime. Let's keep scrolling here. Prime numbers, now we know. The first primes were those 2, 3, 5, and 7. The next 4, you just look and you can eliminate through here. 9 is going to be prime, not prime, but 8 is also not prime. Hold on, let me look at this a little bit. All even, okay, so it's eliminating it by the rules we know of divisibility. So you cross out your evens, those can't be prime. Cross out those that are divisible by 3. Then you end up with what ends up truly being your prime numbers. Give you a lesson activity 3 sheet to complete this activity here. You don't really need to circle the numbers. Well, here, it says you'll have 1 to 100, follow the directions, draw a line through 1, we said can't be prime, circle 2, draw a line through all the other multiples of 2, because those are not prime either. And we'll just work through what we just kind of did, and then you'll end up with a prime number chart. Anything that's not crossed out are your prime numbers, and those will be useful for the future for factorization and such. So you have to make sure you know what a factor is. So let's do pick 2 from here. Which number in each group is a prime number? Pick 1. Which number is not prime? Let's do all 3 of these. And let's do letter L. So 7 total. Thank you.